you know, there are some in the group that have not had it before. So I usually take it real slow at the beginning, and then we move on as we get into the properties and the laws. We move on kind of, you know, not fast, but a little bit faster. So what is and I got into this a little bit with you with the difference quotient. The reason I have my video off is I'm going directly to my whiteboard. And everybody should be able to see my whiteboard. I told y'all that the idea of calculus is a merge between limits and algebra. And the algebra is the difference quotient. And does everybody remember what I told you the difference quotient was? It's a fancy way of saying what? The slope.
Slope.
So I did cover that with y'all?
Yes.
Okay. So the slope is the same thing as the difference quotient. Now the limit theory basically says this, and I want you to listen to what I'm going to write down. If I take a large step toward a wall, then take half of the previous step, will I reach the wall? Yes or no?
You will get infinitely close to the wall, but you won't reach it.
Yes, you will get very, very close to the wall, but you never will touch it. Okay, now that's the limit theory. Now I'm going to show you how we apply the limit theory to the difference quotient, and we come up with calculus. All right? So, and if you don't believe me here, let's say that I take a 6-foot step. Then I take half of that, that's 3 foot. Then I take half of that, that's 1.5 feet. Then I take half of that, that'd be 3/4 of a foot, and so on. You never will reach the wall. Mathematically, you never will reach the wall. And that's called convergence. All right? Limit theory basically talks about convergence. I put it quotation mark because I don't know if that's an E or an A, but convergence. So how do we do this? Well, I'm going to show you. Now, I'm going to take off from what I showed you with the difference quotient. So I'm going to take my handy dandy graph, and we're going to draw a y-axis, and we're going to draw an x-axis. And I'm going to draw a curve. And I'm going to take 2 different colored dots. And I'm going to put a blue dot right here. I'm going to drop a blue line here. And I'm going to put a blue line there. And that's called x. And it's called f of x. And then I'm going to go up here. And I'm going to put a... Oh, I thought I was hearing things. That must be you, Mr. Wiggins. Okay, thought I was hearing things. All right, and this green line or green point is going to be x plus h. And this is going to be f of x plus h. Now, I told y'all that if you connect these two, That's called the secant line. Now, I want you to write that down because it's very important that you understand that. If you connect those two dots, that line is inside the curve, which is called the secant line. And I'm going to draw this curve on up here like this so you can see that we're dealing with a curve. Okay? This is called the secant line. Now, the secant line is what you find with algebra. All right? Algebra is what you do. M is equal to delta y over delta x, which is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And we did that, blah, 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 blah. You get f of x plus h minus f of x over x plus h, which x minus x plus h, which that takes the x's out, so you're left with h. And that's where you get the slope of the secant line. But that's not what you want in physics and calculus. Can anybody tell me what line do you want in physics and calculus? Anybody? Not the secant line.
Tangent
Anybody?
line.
The tangent line. And that's the goal. The goal in calc and physics. Now, I say physics because I'm used to teaching the 140, but in this case, it'll be business and marketing, okay? The calc and physics, you want the tangent line. And where is the tangent line? Well, what you do is, I'm going to draw a red. This is red. I don't use red unless it's very important. If I decrease h, if I bring, here's my 6-foot step, here's my 3-foot step, here's my 1.5-foot step, here's my 0.75 step. If I apply the limit theory and I bring this h toward x, what will happen to this point? It'll start coming down. Everybody with me? And that point will keep converging onto this point. So the distance is approaching 0 feet. So my green point is coming down, and it's coming down, and it's coming down, and it's coming down till it gets within a hairline of that first point, that blue point. And when I get, you got to think in terms of a hair, the width of a hair. Okay, when you get to width of a hair, and they're not touching, but they are a width of a hair apart, then that secant line becomes what? The tangent line. And the tangent line looks like this. And these tangent lines look like this. So in order to make the secant line turn into the tangent line, the distance has to approach what?
0.
Okay. The distance, which is this distance, this red distance right here, has to approach 0. Now, of course, if the x decreases, the distance between x and x plus h, then this decreases, and that's called the squeeze theorem. The squeeze theorem is as x approaches 0, y also approaches 0, so you come back down to that red point right there. And that red point and that blue point are within a hair's width of each other. Now you can think out of the box as much as you want. You can say 1/100th of a hair width, but you got to think they're not touching, they're side by side. And it's almost the width of a hair or less than a width of a hair between those, that blue point and that red point. and that turns the secant line into the tangent line. And that is the goal of calc and physics and marketing, whatever, okay, in business, to find that tangent line. Because once you find the tangent line, you can find the normal vector, which is 90 degrees off the tangent line. All right, and that's where that comes from. Now, the limit theory is usually written like this. Limit as h approaches 0 of some function. And you can go x squared plus 4x plus 4 over x plus 2. Now, this is an example of a limit function. Now, there's two things you can do with a limit function. One is you can simplify it. You can simplify, then solve. Or you can just solve. All right. Now, you can't have 0 in the denominator, so this one is simplifiable because you can factor the top. We'll get into that later. All right. The main thing you need to realize is this is the way that a limit is written. Now, with the difference quotient, let's move on. I'll show you how the limit applies to the difference quotient. Let's say that I give you a function, and this is going to be real simple. I want y'all to use the difference quotient on the following function. This is what we did in the review. F of x is equal to x squared plus 2. Now, you know from the review section what this looks like. Will somebody tell me what this looks like? What does this look like before we even get started? What does it look like? That means I want y'all to interact with me.
I think I'm wrong, but quadratic function?
It's a quadratic, yes. It means it's a parabola.
It's going to look like
What
a
else?
U.
It's going to look like a U, which that's a parabola. But what is that to? Is that a vertical or a horizontal shift?
Horizontal.
No, it's got to be attached to the x. It's got to be within the square to be a horizontal shift.
Oh, vertical. Sorry, I just woke up, Hubert.
That's all right. You're drunk. We understand. All right, here we go. There we go. So we know this is what the function looks like. All right, now I want y'all to take the difference quotient, and I want y'all to apply the difference quotient to this function. Go ahead and do that. And I'll go ahead and give you, because I know some of y'all done forgot, even though we just went over it. F of x plus h minus f of x over h. What I'm fixing to show y'all is the merge between the limit theory and the algebra. Right now, we're just doing algebra. So I'll give y'all a minute to do that. Give y'all a few minutes to do it. If you can't do it, just remember that you're a failure.
Well, that's definitely some motivation.
Good, good. I always
Don't
try
wanna-
to motivate my students. I didn't say.
I don't want to be a
Mr.
failure, Hubert.
What?
I don't want to be a failure, Hubert. I'll do
Oh
this
well,
just.
you're in the wrong class because that's what I teach in here. You need to get into one of those motivating classes. Oh me, do you know? Y'all know? I actually told a class one time. You know how I say stuff like I say to Miss Holcomb sometime, I'll say something like, well, I would have given you points, but I don't like you, so that's why I didn't give you points. I actually had a student, and I said that to the class one time. I said, well, this class, I really don't like this class, so I'm not going to do this, blah, blah, blah. I had a student actually go to my department head and tell my department head that I didn't like the class. These people want to form a revolution. They can't even make a ham sandwich. They don't even have a sense of humor. I mean, anyway. And y'all can tell that I like y'all by the way I act. I mean, it just makes no sense. Some of these people, I just don't understand. How do you operate in real life without a sense of humor or the ability to communicate? How do you do that?
I feel like people nowadays are too sensitive, Hubert.
Well, that's why. What were you
They're
going
just
to say,
weaned on a
Mr.
pickle.
Barry? I'm sorry, what?
I said they're just weaned on a pickle.
They're weaned on a pickle. There you go. See, y'all are learning something in here. Mr. Barry, you were going to say something. What were you going to say? I'm sorry, you got cut off.
Oh no, I agree with you guys. I'm just being quiet and drinking my Mountain Dew.
Well, at least you're smart enough to know that there's two things you drink in the morning: Mountain Dew, or what some of y'all drink, coffee. Okay, Mountain Dew and coffee. That's the most caffeine you can take. Yeah.
I have a rather crippling Mountain Dew addiction. It's pretty bad.
Well, Mountain Dew is easily. I was addicted to it when I was a teenager, and I still drink Diet Mountain Dew because I don't need that sugar. But the Mountain Dew and the real Mountain Dew also. I like the real Mountain Dew too, and I'm talking about the clear kind. But the green Mountain Dew, it's addictive also.
It's like
All right.
coffee. So wait, wouldn't the answer to this be? Wouldn't it be x times h, or just x plus h?
Well, that's what I'm fixing to do right now because I have no idea. I haven't done it, so I'm fixing to do it. So I'm going to rewrite this, and I'm going to put brackets right here, minus brackets. And that stands for the f of x plus h and the f of x. And that's all going to be over h. Now, remember, we did this in the review. So y'all should, be able to do this. I'm going to rewrite this with parentheses. Parentheses squared plus 2. And then over here, I'm going to rewrite x squared plus 2 because that's f of x. See? F of x is equal to that whole thing. X squared plus 2. And somebody tell me what I'm going to put in those parentheses right there.
X.
X what?
Squared.
X what?
Oh, x plus 2.
No.
O plus h.
X plus h. Because when you have something in parentheses, that means you're going to plug in whatever's in parentheses. And there it is right there. Now, you're going to do shortcut number 1, which some of y'all have refused to learn. And I'm going to put that in orange too. So that'd be x squared plus 2xh plus h squared. And then I'm going to do the rest in black, plus 2 minus x squared minus 2 over h. Now, somebody tell me from the review what should happen when you do this. What should happen?
The x squareds and then the 2 should cancel out.
The non-h terms, that's right. The non-h terms should cancel out. So the negative 2 and the positive 2 cancels. And then the negative x squared and the positive x squared. Now, they're not going to all cancel out all the time, but something is going to cancel. All right? They just make up for it with a heightened sense of self-importance. Wow. Miss Holcomb, that is out there. That's deep. All right. So I just saw that. I just pulled up the chat. So we got 2xh plus h squared over h. And to simplify this, the most simplified term, I'm going to factor out a h and cancel, and I get 2x plus what? H. Now I need for everybody to tell me. I'm going to go ahead and go to the. Okay, I want everybody to throw up your virtual yellow hand and leave it up if you understand and got 2x plus h. Let's see all the hands. Come on, leave them up. Waiting, still waiting. Keep your hands up. I'm waiting to see how many. Okay, I got a few people that don't have your hands up. Do you have questions on it? They're probably eating breakfast or they went back to bed. Anybody got questions? Okay, out of the number that we have here, 1, 2, 3, 4, 5, 6, 7. Out of 21 people, I got 7 people, so 14, 2/3 of the class are okay. Anybody want to ask a question at this point? Okay, that means they're either not listening or they don't have a question, one of the two. All right, so I'm going to move on. You can take your hands down, put everybody back in alphabetical order. Thank you. All right, now we've done the algebra. Write this down as algebra. Now we're going to apply the limit theory. So I'm going to take this thing right here, that item, and I'm going to apply the limit theory. Limit as h approaches 0 of 2x plus h. So somebody tell me from your algebra days, what happens when we are pre-calculus days? What happens when we do the limit as h approaches 0? Does anybody remember how to do a limit? Okay, I got 3 people need to take your hand down, please. So put everybody back in alphabetical order, please. So I can call the roll or, do the roll. Anybody got a question? Let me go back. Somebody just chatted. Hold on. What does that say? Sorry, my laptop froze. Oh, okay. Does anybody have any idea how to do a limit? Okay, this is what you do when you do a limit. You mentally or physically plug in 0 for h.
Yeah.
So I'm going to get 2x plus 0, which is 2x. And 2x is the derivative of, what do we start with? X squared plus 2. Now, I want you to write that down and highlight it, because I'm going to ask you, what does the derivative mean? And most of y'all will say, I have no idea. Mr. Barry, your hand's still up. Okay, so 2x is equal to the derivative of x squared plus 2. Now, what is the derivative? The derivative, oops, I'm sorry. Derivative is the equation for the slope of the tangent line anywhere on a curve. The derivative is the equation for the tangent line anywhere on a curve. All right, let's put it to a test. We said that we were going to find the difference quotient for x squared plus 2. So I'm going to go to my next page, and I'm going to draw a top hemisphere graph. And I want you to do this also, especially for those that's never had calculus before. So I'm going to draw a y-axis in the middle of my page. And I'm going to draw an x-axis about 2/3 of the way down, or a quarter of the way up, whatever you want to call it. And I'm going to plot 2 places up, and we know, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. I don't need these, but 3, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Y'all are impressed, aren't you? Anyway, let's go with, you can plug in the numbers. Let's go with 1, because we did 0. 0 plus, let's see, 0 plus 2. So 1 is going to be 3. So 1 is going to be 3. Now let's go with 2. 2 squared is 6. 2 is going to be 6. So that's 3, 4, 5, 6. There's a reason I'm being very accurate, or trying to be very accurate. Just give me a second. Okay, so I've got a parabola. Let's go with 3. 3 squared is 11. 3 squared is 11. So we're looking something like this. Now, Miss Holcomb, since you will talk to me, pick an x along this function. Pick one of these x's down here. Just pick one of the x's. Okay, she done went to sleep. Oh, 2. 1, 2. So I'm going to put a circle around this point right there. And I'm going to take my function, my derivative, and I'm going to put f prime of x is equal to 2x. And I'm going to plug in x is equal to 2. So the slope of my line at that point is 4 over 1. So that means 4 up, 1, 2, 3, 4, and 1 over. And that is my tangent line. Well, don't have it exactly right, but. And that f prime of x is equal to 2x. So the slope of my line, my tangent line, at x is equal to 2 is 4. All right, now, somebody pick a negative x. Somebody pick a negative x for me. That means I want y'all to interact with me.
-3.
Thank you again, Miss Hollister and Miss Holcomb, for, I don't know what I'd do without y'all. The rest of y'all suck. -3. So -3 is up here. So I'm going to draw a circle around that -3. And I'm going to plug it in. So f prime of x. And I could plug 2 in right here. And I can go f prime of -3 is equal to 2 times -3, which is equal to -6 over 1. So 1, 2, 3, 4, 5, 6, and over 1, be right in there.
So whatever number you choose, you just plug that in for x and then solve it.
Bingo. Bingo. And that is the tangent line. Actually, it goes on up. That is the tangent line at that point. And f of x, f prime of x is equal to 2x. That's the equation of this line. And it's the equation of this line. Okay? And if you plug in the number, you will get the slope of this line, which would be -6. M is equal to -6. M prime is equal to -6. And over here, M prime is equal to positive what? 4. And that's what you're finding. So write that down, because that is what we're doing. That's your goal for derivatives. Now, that's a simple derivative. Now, we're only talking about, you know, a simple x squared term. Okay? Talking about a simple x squared term. Now, I want to show you a trick I learned in the war. What about f prime of 0? Somebody tell me what you get there.
0.
And what do you get when the slope is equal to 0? What is that called?
Undefined.
No, that's a vertical line. What's the opposite of vertical line?
Horizontal.
Infinitely many solutions.
Horizontal line. And that is right here. Now, I want you to make a note of this, because this is going to carry into your marketing. That right there is going to carry into your marketing. M is equal to 0. So at the vertex, no matter what kind of parabola you have, the vertex will always give you a slope of what? Slope of
0.
Yes. Remember that. You're going to see that in marketing. For some of you business majors, you're going to see that. All right, let's do a nerd. Now, I'm showing you where we're going with derivatives, okay? So I'm going to make sure you understand what a derivative is before we move on. So I want you to do the next one. I want you to do f of x is equal to -x squared minus 3x plus 2. Now, you better save yourself a half a page. Mr. Barry, you need to take your hand down again. I don't think he heard
My bad,
me.
I didn't know it was still up.
That's all right. Okay, so go ahead and do this one. Use your difference quotient and apply your limit theory. And we're going to see some more problems with the limit theory. I'm just trying to show you where we're heading. Okay.
Hubert, do you teach business calculus?
I teach, yeah, I'm teaching it right now. This is business calculus, isn't it?
Oh, I didn't know what, I thought it was called something different.
This is 130, isn't it? Yeah.
Yeah, it's business calc.
God, you scared me there for a second.
You
I
scared
thought, oh
me.
my God,
You
this is
scared me.
109.
I didn't think that was the name of this actual class though, but
This is
okay.
Business Calc 1. Now, I'm going to try to teach you as much as I can because Tri-County Tech believes that all the business calculus and the calculus 2 and 3s need to be taught at the Pendleton campus. So you will have to take 230 at the Pendleton campus. Don't ask. I have no idea why they do that. I think it's because there's not many students that take it. So therefore, they, teach it at the Pendleton campus so it will make. That's the excuse they use. And be prepared. That's all I'm going to tell you. Be prepared.
Well, I was asking because I'm going to have to take it at Clemson, so I'm sure that'll be no better than the Pendleton campus.
It's neither one. They're the same. The thing I would tell you is you got a better chance at getting a better teacher at Clemson.
Yeah, I agree.
You can try it. Now, there is one teacher. There is one teacher at Pendleton, and I'm not going to say her name, but she is pretty good as far as explaining things. But I'm going to let you decide if you do take 230 at Pendleton campus, look them up on Rate My Professor, and you'll be able to tell because there's only 3 that teach it. I did teach it, but then when they decided to move it to Pendleton campus, I don't teach it anymore. So that's all I'm going to say. Make sure if you take it at Pendleton to look at Rate My Professor, and if it says good stuff, then you can stay in it. But you only got a 33% chance of that.
Honestly, did you want us to find the difference quotient? I'm sorry.
I want you to find the difference quotient and then apply the limit theory.
Okay.
Limit as h approaches 0. It may take you a few minutes, but that's fine because we're going to spend a lot of time doing this, finding the derivative. But the reason I'm showing you the difference quotient is so you will appreciate the calculus laws of derivatives. You won't have to do all this work. Gas prices keep going up. I paid $2.59 for diesel yesterday. It was $1.90, but that's okay. People in DC are getting rich off the Ukraine. That's all that matters. Ugh. Shut up, Hubert. Shut
Hubert,
up.
did you hear what happened in Texas? That's awful.
Yep, I did. And I think there's somebody that needs to explain why Texas is in the state that it's in. Not, no pun intended, state meaning why they can't. No, it's a mess.
It's in the state that it's in because it is a state and it shouldn't be a state.
Exactly. But there's some people that need to explain why the power failure started out there. I mean, there's some people that need to explain that because 21%, you can't blame it on the new energy because only 21% of the energy in Texas is from windmills or solar. So you can't.
Yeah, that's what they're trying to blame it on.
What?
They're trying to blame it on the wind freezing the pipes.
It's not that because only 20% comes from solar and wind. So you got 80% coming from hydro. You got 80% coming from coal. You got 80% coming from electric. So, you know, somebody's got to do some explaining.
Well, Hubert,
Yeah.
did you see that Arkansas, like a year ago, they passed a cold weather kind of bill or whatever, and they bought a few plow trucks, and Texans laughed at them. And now there's pictures of, like, there's a highway that half of it is on the Texas side, and half of it's on Arkansas side, and they only plowed the Arkansas side.
Yep. I saw something like that on, but you know, I think that's what's the planning. I think that's, you know, that somebody's got some explaining.
They weren't prepared.
Yeah, they weren't prepared. It's kind of like Katrina. You remember Katrina, Hurricane Katrina?
Yeah.
And there was buses upon buses upon buses that were underwater that could have been used to evacuate people out of New Orleans. That was nothing but poor planning. And a hurricane doesn't just come up on you like a tornado. A hurricane, it takes weeks for a hurricane to reach you. No, that Hurricane Katrina was poor planning, period. Anyway, I'm going to shut up. All right, so here we go. I'm going to put brackets here. And I'm going to put brackets here. And I'm going to put H right here. And I'm going to rewrite negative parentheses squared minus 3 times parentheses plus 2. And then rewrite negative x squared minus 3x plus 2. And then I'm going to plug in x plus h and x plus h. And now I'm going to do my algebra. I'm going to do my algebra right here in red, in orange. So I'm going to get, well, I'm going to put my negative out front. Minus 3 x plus h plus 2. And I'm going to go ahead and distribute my negative here. That's going to be plus x squared plus 3x minus 2 all over h. Shortcut number 1 gives us x squared plus 2xh plus h squared. And then I'm going to distribute that negative 3 right there in this negative. So that's going to give me negative x squared minus 2xh minus h squared minus 3x minus 3h plus 2 plus x squared plus 3x minus 2 all over h. And time for a red pen. And on a red pen, we'll take out the x squared. We'll take out the 3x and take out the negative 2. And you should be left with all h terms. Now, it's not going to be 100% of the time that you're going to be left with all h terms. There will be some times that you're left with a 3 or a 4, but that's later, okay? We're just doing basics right now. And I'm going to take my handy dandy black pen, and I get negative 2xh minus h squared minus 3h all over h. And I'm going to factor out a h. Negative 2x minus h minus 3 over h. And the h's cancel. And that leaves me with negative 2x minus h minus 3. That's where we're going to do the limit theory. So, let's do the limit theory. I'm going to go to the next page. I'm leaving that up just in case somebody's a few seconds behind. And we're going to do limit as h approaches 0 of negative 2x minus h minus 3, and plug in 0, negative 2x minus 0 minus 3 gives us negative 2x minus 3. So f prime of x is equal to negative 2x minus 3. Now, notice I said f prime of x. The derivative of f of x is f prime of x. Now, you got to get used to seeing it like this. The derivative of y, because that can be written as y, is y prime. So it depends on who you have or what book you have. It may say f of x is equal to this, or to this, sorry. F of x is equal to this, or it may say y is equal to this, or it may say, yeah, it'll say one of those. And then there's cases when you have dy over dx.
So the derivative's negative 2x minus 3?
That's the derivative, yes.
Okay.
And I put f prime of x right here because the derivative of f of x is written f prime of x. The derivative of y is y prime or dy dx. You're going to see all three of these you'll see in the future. So I want you to take a highlighter. I'm going to take a pink highlighter and I'm going to highlight this little accent symbol, which is called prime. And you're going to see it written like that, one of these three ways. Now, I don't know what Unit 1 does as far as explaining all this to y'all. I'm sorry, Chapter 1. So what I would like to do is I want to go back and look at that outline and see what they actually cover. Because I'm going to try to cut away a little bit of the fat on that, on the limit, because they do a lot of stuff that you don't need. Unless y'all just want to do all that extra stuff. I don't think y'all do. One, two, three, four, five, six, seven. Oh my Lord. Okay, let me look and I'm gonna highlight the stuff that's important. Okay, right now we're doing 1.4. Hubert, you skipped 1.1 through 1.3? Oh, I've already covered it. I gave you a lot more in the review section than you needed. Okay, and this is where you change the 1.4 is what we're doing right now. The power, sum and difference, product, quotient rules. Okay, 80% of your test is going to come from those sections right there. I want you to write that down. 80% of your Unit 1 test is going to come from 1.6 through 1.8. 20% of your test is going to come from 1.4, what we're doing right now. Okay, so I'm going to show you the slides from 1.1 through 1.3, and hopefully I'm not going to cover 1.5, so take that one out. Mark through 1.5 because I don't have time to go over that. Lipnitz, I don't have time. So we're going to look at 1.1 through 1.3, and that is just to make sure you understand how to do the homework. So let me pull up the handy dandy homework for one. Let's see, that'd be instructor tools, resources, PowerPoint. Where's the freaking PowerPoint? There we go. And 1.1. 1.2, and 1.3. And I'm not going to go over them detailed. I'm just going to go over them, just skim over them. All right, so here's 1.1. And I condensed a lot, so they may be showing you the long version of what I just showed you. So we'll look and see. Objective, here they're showing you converging, limit, Okay, here is what we've already talked about. You remember me doing that problem where you factor the top and cancel the bottom? All right, so let's do this one because this is a homework problem. And you could have a couple of these on the test, but I probably will go straight to the, always check when you're doing one of these problems, limit, this is strictly limit. Okay, this is nothing but limit. Let me move this down. So you got f of x is equal to x squared minus 9 over 3x minus 3. And they tell you down here, they say, what is f of 3? A. What is f of 3? Now, this is a standardized test question also. They love to put these on standardized tests. Why? Because students miss them. Somebody tell me what you think the answer is.
0.
0 is wrong.
It's 0 over 0, which is undefined.
That is wrong. You see why people miss it? Because they think that 3 is plugged into that, and you get either undefined or 0. That's why they miss this question. You got to do the algebra first. So I'm going to put a red marker under this. Algebra, what?
Oh, it can also
Algebra
be
first.
6. Yeah, 6.
Okay, so what are you going to do with this before you plug in that 3? You're going to break it up. Shortcut number 3 right here. Shortcut number 3 gives you, I'm going to do it in red because I put algebra first in red. So I'm going to do the algebra in red. X plus 3 times x minus 3 over x minus 3. And what happens?
It cancels.
And you're left with x plus 3. And now you plug in limit as x approaches 3 is 6, as Mr. Berry said. Now, what the heck does this mean? Well, we're going to go to the graphing calculator and we're going to graph this. And the reason we're going to graph it is it's easier to graph with calculator than by hand. Y is equal to, and this is the kind of questions you will see about limits. Turn it on first, Dork. Y is equal to, parentheses, clear, parentheses, x squared minus 9. Ugh. Hold on a second. Delete, delete, delete. X squared. I'm losing it. Minus 9, close parentheses, divided by parentheses, x minus 3. And graph. That's not right. X squared minus 9 divided by x minus 3. Why is it not graphing a curve? Graph, well, I'm not going to worry about it. Let's do the first quadrant. Okay, does everybody see that dot right there? That there's no. Everybody see that little area right there? Go to your, zoom in if you want to. And just zoom in right about here. Well, that wasn't worth the crap. Zoom out. And I'm going to zoom in again. Does everybody see that little dot right there that there's no line? See it right there? Well, move my cursor out of the way. Does everybody see it? Well, that's x is equal to 3. Because x is equal to 3 is what? Y'all said it a while ago. Not 0, but what? Undefined.
Undefined.
That's right, class. So we're going to draw a blow up of this. And we're going to draw that line. Let me zoom out again. Zoom out. We know that the zoom out. There we go. We know it's crossing somewhere here. I don't know where. Okay. But it has at 3, it has an open circle. Okay. And that's what that represents. This right here, you need to make a note, a mental note at the beginning of the problem. A mental note that x cannot equal 3. And that's what that open circle means. Then you do the algebra. All right? And that means, and this right here means, that the limit is approaching 6 at x plus 3. All right? So that's the answer. 6 is the answer. This is nothing but a limit question. What they are trying to get you to learn here is how to deal with a limit. Okay? They're trying to get you to understand what a limit is. A limit, you are converging onto, a certain number, and what do you get? You get 6. Usually this is x, and I'll write that down. Usually this is your input, and this is your output. Usually. So let's look at the question that they asked. If I can find my PowerPoints. Well, let me get out of this. There's the question. And of course, you see that you can't have, so the limit does not exist. But if we use algebra, and they didn't do that, but you see it's approaching 6. And there it is right there. So you have to use limits and you have to use algebra together to find out about your limits. So that's a good test question right there. So you might want to write that one down as an example of what I would ask you out of 1.1. Let's look on down and see what else they show. Really, I don't get into those. These, they just ask you, what are you approaching? And if you are 2x plus 2 and x is less than 1, then you're going to plug in like 0.99999 into that. And x is above 1, and you can plug in 1 or 1.00001, and you can plug that in there. And that's what they're going to show you here. Like right there, it's 0.9999. You're approaching 4. And on the other side, as you get higher and higher and higher, you're approaching 0. So they're trying to show you convergence. Now make a note of this, and you're going to see this in other classes, and that is where you see this negative. All right? When you have a negative on the right side of the number, and write this down, When you have a negative on the right side of your number down here, that means you're approaching from the right. If you have a negative here, a positive here, that means, I'm sorry, negative means you're approaching from the left. A positive means you're approaching from the right. Now, what does that mean? Well, let's go to a whiteboard. And let's take, for example, that graph that we did a while ago. And that's 1, 2, and that was that number. And then we had 1, I think 1 was equal, what was it, x squared plus 2, that'd be 3. So 1 would be 3, and 3, and 2 would have been 5. I can't remember, be 2, 6. 2 would be 6. All right, so here's my graph. And that's the graph we drew a while ago. If I take my, and let's say that this is 1. If I approach from the right-hand side, if I approach 1 from the left-hand side, from the right-hand side, that would be positive. I'm approaching 1 from the right-hand side. What am I approaching in the y direction? Well, as x comes down, I'm approaching this number right here. So that would be 3. All right. So am I approaching from the right? If I'm approaching 1 from the right, my limit is 3. If I'm approaching 1 from the left, my limit is 3. If I approach from the left and the right, and I get the same number, the limit exists. It's got to equal the same number, though. Now, you're going to get into this into 1.2 or 1.3, where the limit exists and does not exist. And if something doesn't ring in your memory, you send it to me and we'll go over it as needed. Okay, but you will send me questions in the homework and I will tell you if it's needed or not. But I can tell you this, it's just going to be the limits. It's not going to be derivatives until we get to those difference quotient, which is in 1.4. So this is a limit question. If you approach x is equal to 1 from the right, you're approaching 3. And I'm going to take my red marker and I'm going to do this. As I approach x is equal to 1 from the right, on my graph, I'm approaching 3. As I approach x is equal to 1 from the left, on my function, I'm approaching 3. So the limit of this function at x is equal to 1 is 3. And that's why the limit exists. And you could say that. You could go up here, and I'll do it in magenta. I can say legally that limit as x approaches 1 of, what did I say this was, x squared plus 2 is equal to 3. I can say that with 100% confidence because I have no breaks in my line, and my positive from the positive direction and the negative direction equal the same thing. Y is equal to 3. So therefore I can say that the limit as x approaches 1 from the right and the left of x squared plus 2, I'm going to get that number for y. And that's what limits do. You're talking about converging and converging. All 1.1 through 1.3 is talking to you about is convergence. So let's look at some more slides. And that's what they're talking about here. Now, look at here. Here's a good example of non-convergence. What's happening as I approach 1 from the left, from the right? As I approach 1 from the right, what's happening? I get -2. As I approach 1 from the right, I get -2. As I approach 1 from the left, I'm approaching 4. 4 does not equal 2, therefore, 4 does not equal -2, therefore what? The limit, what?
Doesn't exist.
Does not exist. Thank you. After the third time I went across it, thank you. All right, so this is a good test example for a standardized test. Okay, so right now I've given you 2 questions that I would give you on a test. One was the first one we went over, that one right there. And the second one, I could give you something like this or something like this. So we're talking about 2 questions out of 20 or 30 questions, 2 out of 1.1. Okay, let's see if they give you a graph on this one. Okay, same thing here. Now, this, I'm just gonna do, what happens when I approach 1 from the what? From the right. As I approach 1 from the right, I get negative what? 2. Well, what are they saying? Wait a minute. Why are they doing, they're doing negative, okay, -3. As I approach -3 from the right, what am I approaching? -4. As I approach -3 from the left, boom, I get -4. So that's what I was showing you a while ago. Okay, I'm sorry. I thought they were approaching 1. Okay, I'm sorry. I just read it wrong.
So when you're approaching a line, where do you start at?
You always start, you look at the X. See what it
Okay.
says right here? X is approaching -3. So you have to zero in on that -3 right here. That's where you're approaching. Whatever this number is right here, that's where your eyes should lock first. Does that help answer your question?
Yes, it does.
Yeah, that's what you should focus on. And you should focus on, if I'm approaching from the left and the right, what is my Y? And in this case, it would be -4. So the limit exists. The limit is -4. And they're showing you here what doesn't exist. When it doesn't equal the same thing, it doesn't exist. All right. And I'm looking, looks like they're approaching 1. And 1, you get -2. 1 from the left, you get +4. And actually, you get 3.99 because that's open circle. That does not exist. Now, this one does exist because it's -3, not +1. That's the same thing. I'm not worried about that. That's the same thing. Okay, what happens if you have something like this? Well, all you got to say is, as X approaches 2 from the left, what is my Y? Well, I don't have a Y. What if X approaches 2 from the right? I don't have a Y. I have infinity. Negative infinity does not equal positive infinity, so therefore what? Does not exist. Now write this one down, because this is one they love to put on standardized test. They love to put this one on a standardized test. As you approach 2 from the left, you're approaching negative infinity because it's pointing down, see? The y is approaching negative infinity. If you approach 2 from the right, you're approaching positive infinity. So negative infinity and positive infinity. Now, what if you have a volcano? Then it's different. And then they also like to put this one on your, and I'll draw it right quick while you're drawing that one. Well, I should have drawn it a little bit closer. Let me draw a little bit closer. What if I give you this one? What's happening as I approach -2 from the left? I get positive infinity. What happens when I approach -2 from the right?
You get positive infinity. Positive infinity.
Positive infinity. So the limit as x approaches 2 is positive infinity, because these two are equal to each other. If the limit equals each other, you have a limit. If it doesn't equal, it's not a limit. It does not exist. And that's probably what they're going to show you next on the PowerPoint. Well, I don't know if they're going to show you that or not, but see, here's another one. As x approaches 2, negative infinity. If x approaches 2 from the right, positive infinity. So there's no limit at x is equal to 2. But what about at x is equal to 6? X is equal to 6, you're talking as, well, I'm trying to find one. Hold on. Yeah, you could say right here at 2.5, you could say, or 2 1/4, you could say it's 8. But at -2 1/4, or -2 1/4, it's negative infinity, so that doesn't exist. I'm trying to find one. Okay, so that's basically. Now, if you noticed, I stuck to slides that showed you what? The graph. Are most of these questions going to be on the graph? Yes, except for the one I showed you at the beginning, which is the algebra question, which I can't find right now, but that one. That's the only one that's technically algebraic. The rest of them will be pretty much on a graph, like that one, or like that one. Well, not that one. Well, this one. Does it exist? No, it doesn't exist, because you're approaching 3, but you're not hitting 3 because of the open circle. Versus if it was a closed circle, you would be, hitting it. Okay. You could say 3, but you're approaching 3. Okay, let's look at 1.2. Well, we're done. Okay, what I want y'all to do for homework, this is what I want you to do. Right now, y'all are working on the test and the final homework, and I understand that. Some of you that have finished your test and finished your homework, if you want to read and try some problems on chapter 1.1 through 1.4, you can do that. The rest of you work on your test and your homework. And, if you've done your test and your homework and you don't want to move ahead, then just relax, and we'll probably start Tuesday with actually covering. You should be able to work on 1.1 at least today. But, you know, just work and let me look at the attendance right quick and make sure everybody's here that wasn't here Tuesday. And of course, it's probably going to log me out, and it did. So frustrating. Hold on, I got to re-pull everything up. Let me cut the attendance off. I meant the recorder off. I'm just making sure